So now I'm going to have a go at the next Codility exercise. It's called Peaks and it's in lesson 10. Let's get straight into this. Okay, a non-empty array A consisting of n integers is given. A peak is an element in the array which is larger than its neighbours. More precisely, it's a number p between 0 and n minus 1, where AP minus 1 is less than AP and AP is greater than AP plus 1. So for example, in the following array, the peaks I think will be there because 4 is surrounded by 3 either side there. So we've got 3, 5 and 10. Yeah, 3, 5 and 10. We want to divide this array into blocks containing the same number of elements. More precisely, we want to choose a number k which will yield the following blocks: A0, A1 to AK minus 1, AK plus 1 to A2K minus 1. I'm not quite sure what this means, but let's carry on and work it out if I can't work it out. What's more, every block should contain at least one peak. Notice the extreme elements of the blocks, for example AK minus 1 or AK, can also be peaks. Right, okay, so that's one block. It goes from A0 to AK minus 1. The next block goes from AK plus 1 to A2K minus 1. So, and that's the final block. So K is the length. So if we want to split, if K was 3, that'd be the first block, that'd be the second, that'd be the third, that'd be the fourth. Okay, notice the extreme elements of blocks can also be peaks, but only if they have both neighbours. The goal is to find the maximum number of blocks into which the array A can be divided. So this array, which is written there because that's it in one block form, it contains 3 peaks. 2 blocks, because there's 12 elements, we split it into 2 lots of 6. Every block has a peak because there's a peak in that block and there's a peak in that block. 3 blocks of 4 each, every block has a peak. Notice in the first block 1, 2, 3, 4 has a peak. Okay, so this is meaning that this is a peak in the set, and we're looking for blocks that contain a peak in the entire set. It doesn't necessarily have to be a peak in that block. However, A cannot be divided into 4 blocks because this block and this block do not contain a peak. Notice in particular that 4, 3, 4 block contains 2 peaks. Yeah. The maximum number of blocks that array can be divided into is 3. Write a function that, given the non-empty array A, returns the maximum number of blocks into which A can be divided. If A cannot be divided into some number of blocks, the function should return 0. Okay, so unless it's like one big valley with values descending and then ascending, if there's a peak in there at all, then it will be 1, but if it's a valley, it should be 0. So given that array, the function should return 3. Right, an efficient algorithm for n is an integer in the range of 1 to 100,000, so you don't have to worry about it being empty. If it's 1, it can't be a peak according to the rules of being a peak. It has to be 3 in order for the middle one to be a peak. But anyway, n is an integer in the range of 1 to 100,000. each element of array A is an integer in the range of 0 to 1 billion. Okay, so I'm not sure what I'm going to do, but I'm going to just go for it. So I'll just prepare the class and paste the example in. Okay, so I think the first thing I'm going to do is loop through the whole thing and find the peaks. This is like a combination of two different ones that we've done before. I think in the flags exercise we look for peaks, and the other one is the count factors exercise, because we're gonna have to, it needs to divide into an equal number of blocks. So 12 will divide into 6, 4, 3, 2. We can't do 1 because everyone cannot be a peak, but we can divide it into the number of sections which will divide equally. But the first thing I'm going to do, I think it was a flags exercise where we found the peaks. So I'm going to make a list of integers. And I'm going to loop through the array from position 1 to position n-1. So to do that, I'll say int I equals 1. I'd usually go to a length, but I'll do -1, so we go one step back. I++, and now I'll say if a at I-1 is less than a at I, and a at I+1 is greater than a at I, then I is the index of a peak. So peaks add I. Right, so that array at this point should consist of the peak value. So that's 0, 1, 2, 3, 4, 5, 7, 8, 9, 10, 3, 5, and 10. I'm just gonna comment that in there, so because as I'm doing the rest, I think I'm going to think about this example, because it's just an example that we've got. So now what I want to do is divide it. Now if it's not a valley, I'm going to deal with that first, because I know if it's not a valley, then I could definitely return 1. If it is a valley, then I've got to return 0. And I can easily test if it's a valley by saying if peak size equals 0. So if we didn't find a peak at all, then return 0. Now also at the top, I'm going to deal with the fact that if it is 1, it can't be a peak. This will catch it, but if it's 2, it can't be a peak, because say if it was just 1, 2, 2 isn't a peak because there isn't a value after it, and a peak is defined as that in the solution. So if a dot length is less than 3, then we can't do it, so return 0. Okay, so now we've got at least 3 values and we've got at least 1 peak. Now I think what I'm going to do, I could do the sort of count factors thing where we looped from 1 up to the square root and also looked at the opposite side. We're looking for how many blocks we can divide it into, but my variable is going to be block length. So I'm going to start off with a block length. It couldn't be 1 and it couldn't be 2. It can't be 2 because every other one cannot be a peak. Because say if the value was 1 2 1 2 1 2 1 2, the final 2 cannot be a peak because there's nothing after it. So the minimum block length of each of our blocks is going to be 3. So I'm going to loop from, I'm going to call it block length. We don't want to return the block length, we want to return the number of blocks, but I'm going to work out block length. For block length equals 3, block length is less than, I could go to the square root and then work out the opposite one, but I think it will be efficient enough to go to halfway. Block length is less than equal to a length over 2. It's now equal to, because in this case I need to check the block length of 6, and block length plus plus, but straight away if a dot length mod block length is not equal to 0, I'll continue from the loop. So I'll just carry on looping. So if a length mod block length is 0, then the number of blocks is a length divided by block length, and that is a whole number. So now I've got my block length that I want to test, starting at 3. Now what I want to do is look in every peak. I want to see if there's a peak in every block. So I'm going to loop through the peaks. At this point, so I'm going to say int current peak equals 0. I need to say if peaks get current peak, one, 2, 3. So with a block length of 3, the first one is 3. So I want to say if the first the peak at our current peak needs to be less than block length we're okay if that is the case, or rather we found a peak. Found peak. So this found peak is going to be a boolean, and it's going to say, do we find a peak in our current block? I'm also going to say block start equals 0. And I'm going to loop through the blocks with the block start at 0, and then for 3 the next one will be 3 6 9. So block start equals 0 for int the index we're looking at equals block start, I is less than a dot length, I plus equals block length. So that loop block start, or I here, is going to loop block length steps through the whole array. Now this I need to find a peak here. Found peak equals false if the next peak that we're looking at from the current peak position is less than block length. Found peak equals true, and move to the next peak. If it's not, if the next peak is not within the bounds of the block length, we're not looking at block length here, we're looking at block start plus block length. So I'm saying the first peak is at 3. So firstly, block start is 0 plus block length is 3. And I need it to be in 1, 2 or 3. So this won't happen. So we won't find a peak. Else do nothing. But I want to keep looping through until we find a peak or run out of values. So found peak is true and current peak plus plus. So we're going to move through the peaks that we've recorded until we find one which is in our current block. So block start is going through here, block length is 3. So we're going to see if there's a peak there. If there is, we say found peak, and regardless what we do, we go on to the next peak. But here I also need to terminate if current peak, well not found peak, and current peak is less than peaks.size. If current peak is peaks.size, we run out of peaks and we'll get an index out of bounds exception. Okay, so at this point, if we have found a peak, if we haven't found a peak, then we want to break. Give up on this loop and go on to the next. We don't want to break that loop. Okay, here I'm going to add a variable. Okay, and I'm going to assume it's true. And if we find a peak in every block length, then I'll leave okay as true. But if we don't find a peak in any block of block length, then okay is going to be false. And then at this point, if okay is still true, block length is the length we want to go for, and we can return a dot length over block length, and we know that it will divide perfectly because we've checked up here a dot length mod block length is not equal to 0. And if we get, we're still going to have a compiler error because we need to return something, but I think it's possible to get all the way to the bottom of here. Now we've already tested at the top that we're not one big valley. So if we get down here, we've looped up to all values as far as halfway. If we get to here, then we return 1. Now first, I'm not at all confident about this. That was harder than I expected. But let's just see if it comes up with the right answer. The right answer is 3. And then I'll debug it, and I'll also put in some of my own tests for this. Okay, so it didn't work. The answer is 2. So the first, yeah, the answer that it came up with was 2. So let's debug it. And in debugging it, I'll kind of understand more what I've done. Okay, so A length is 12, so we're not going to return 0. Peaks, we want the 3, 5, 10. So I'll just run forward from that and see. Okay, peaks, we got 1, 2, 7, 8, 9. So it's gone wrong. So that needs. Hang on. Yeah, that needs to be less than. Okay, I'll run through again, but I'm going to debug anyway. We've still got 2 anyway. So let's debug again. Peaks 3, 5, 10. That's what we want. Okay, so first we're going to investigate the block length of 3. So block length is 3. A dot length is 12. Mod block length is 4. If it's not 0, we continue, but it is 0, so we're going to have a look. So now we're going to start at current peak 0 and block start 0. So start off at the beginning. We assume everything is okay. I equals block start. Do we need that block start variable? Okay, so I starts at 0. Found peak false. Well, not found peak and current peak. Is there some peaks dot size? Get peaks at current peak, which is 3. That's less than 0 plus 3. It's not. So we don't find a peak in this first one. Current peak plus plus. Actually, if we find a peak, we want to increment the peaks counter. If we don't, we want to break out of this while loop. Let's try that. Does that give us 3? No, it still gives us 2 anyway. Okay, so coming back through, we find our peaks. Right, so the first peak we're not going to find. So this is going to be false. We break out. Didn't put a stop on there, but so we didn't find a peak, so OK is false, and break out of this loop. OK is false. So now let's try a block length of 4. Now this should succeed. So we're starting at I equals 0. I think block start doesn't do anything. I think actually I'm going to get rid of the I here and just call that block start. Block start starts at 0. Because I think I need it there. Okay, back through it, see if it gets the right answer now. 3, it does. But I'm going to do some other tests on this for sure. Okay, so with the 3, we loop through, we don't find a peak. So we break out of the while loop. We haven't found a peak. So OK is false. OK is true. OK, yeah, we set OK to false. Break out the for loop. We're not going with a block length of 3. Try a block length of 4. So we haven't found a peak, but we find a peak here because peaks, current peak, which is 0, is 3, and that's less than 0 plus 4. So we found a peak, and we move on to the next peak. Move current peak on. Now we have found a peak. What if there were 2 peaks in that block? I need to test there being 2 peaks in one block. Okay, we've not found a peak. Now we're on block start of 4. Or rather, we're on the we are on the next section along. We find a peak in there. Move on to the next peak. Move on to the next section. Find a peak in there. Break out of there because block start has now reached a.length. We're still okay. A.length is 12. Block start is 4, 3. Now I just want to know what happens. I'm just going to make some different tests myself. And I'll just do this with 1s and 2s. And my first lot of tests I'm going to do just 12 long. So what if we have, I'm going to make it so that you can divide it into 2 lots of 6. So we want the answer to be 2, but I'm going to put 2 peaks in the first one and 1 peak in the second. Is the answer 2? It's 3. Now I think that's to do with this section up here. So let's just run through that. So peaks now is 1, 3, 10. 1, 3 and 10. So we're trying a block length of 3. The first one's got a peak, the next one's got a peak, but the third one doesn't have a peak. So the first block has a peak, the second block has a peak, but the third block doesn't have a peak. So we're not okay. So we continue. We try a block length of 4. That's going to think the first block has a peak and the second one doesn't. But there's 2 blocks in the first block. So the first block has a peak, but when it comes to the second, it's still going to think it does. So what I need to say, I only want to get out of this loop if peaks get current peak is greater than or equal to block start plus block length. Otherwise I want to keep finding another peak and moving up to the next peak. So if the next peak is going to be in the next block, if it isn't, if it isn't, let me just see if that fixes this one, and then I'll debug and explain it. 3, is that right? No, it should be. Okay, this is tricky. Okay, our peaks are 1, 3 and 10. We try a block length of 3. That's going to find a peak in there, a peak in there, no peak in the third. So there's our first peak. There's our second peak. Now we can't find a peak in the third. And the peak at 10 is greater than 6 plus 3. So we break out. And it's not okay. So we break out. And we didn't find one. So now we're trying a block length of 4. So 4 should find 2 peaks in the first, not 1 in the second. So it finds a peak in the first, but it's not going to break out here because the next peak is also in the first. But it's broken out there. Okay, we just need to protect against that because we don't want to break out. We only want to break out with this break condition if the next peak belongs in the next block. Let's try that. Are we now going to get 2? Yeah. Okay, I'm just going to check that. So peaks are at 1, 3 and 10. Try a block length of 3. We find a peak in the first. The next peak is going to be in the second. Then we find the peak in the second. The next peak is going to be after, in the future anyway. And then we don't find a peak in the third because it's going to be in the fourth. So we haven't found a peak, so we failed. So we drop out of here, come back in with a block length of 4. We want to find 2 peaks in the first, none in the second, and 1 in the third, but we won't get that far. So with a peak of 4, we find the peak in the first. We also find another peak in the first, which makes no difference to the found peak, it just stays true. and then the third peak is going to be in the future, so we drop out there. We found a peak, so we carry on. We now look at a block start of 4. Okay, now this time we're not going to find it, and we're going to break out here because we find that the peak is in the future. So we haven't found a peak, so it's not okay. So we exit. Now we try a block length of 5. That doesn't divide, so we just continue. We find a block length of 6. Now we're going to find 1, 2 peaks in the first, break out because the next peak is in the future, and then we find a peak in the second, break out because current peak is now equal to peak size. We've got as far as this and we're still okay, so we return a.length over block length 2. Right, that was quite a challenge. Let's just have a look at the corner cases. What corner cases can there be? We've dealt with it being a valley. What if it's just level? If it's just level, well, let's try it. So it still consists of 12, it's level. It comes up with 0. Why did it do that? Because it didn't find any peaks. Okay, so if it's too short to have any peaks, we just drop out straight away. If we don't find any peaks, we drop out with 0. We're going from block lengths of 3. We know we can't have 1 because not every value can be a peak. Every other value can't be a peak, so we can't have 2. So we start at 3, we go to half the length, we quickly drop out here. Now we could do this, the technique of count factors, and go to the square root of a.length and then remember the values. If I submit this and it's not efficient, then what I'll do is try again, but I'll loop to the square root of a.length, and then I'll remember the opposite value. So like for example, when we find 2, the opposite value is the length of the array divided by 2, which is 6. So I'll remember those values in reverse order and then work up to the that would be, if you're not sure what I'm talking about, it's in the count factors exercise, but this is how to work out factors of a number. But I think that would be quite a strict thing to make us do, because we're quickly dropping out if it's not a factor there. But yeah, I think that's my solution, and I think I'm going to submit that. I could well imagine that this will fail on some corner case, but let's have a try. I'm just going to import list and array list. Run the tests. We know it's going to pass this example. Submit the task and let's see how it does. "43 minutes. "100%. Okay, so I'm quite happy with that because I found that quite difficult. Okay, so what did it try? Chaotic large sequences, I would imagine that it should have tried some sort of valley, but it seems to have done chaotic sequences, anti-slow solutions, extreme max test. I don't really know what this stuff is, but anti-slow solution, well, who knows. But anyway, that's my solution to the peaks exercise in Codility. Thanks for watching.